Hey everyone, and welcome to This Explainer. I am absolutely thrilled you're here today. If you're gearing up for your IGCSE computer science exams, you've landed in exactly the right spot. Today, we're going to unlock one of the most fundamental and, frankly, coolest topics in the whole data representation syllabus, and that is hexadecimal. We're going to break it all down and make it stick. So get comfortable, and let's get ready to decode the matrix. Here's our quick roadmap for today. We'll start with the binary overload problem, then enter the world of hexadecimal, see exactly why programmers love it, explore some real-world uses, and finish up with a rapid-fire IGCSE exam practice quiz. All right, let's jump right into section 1, the binary overload problem. Now, I want you to picture a programmer working on this massive, incredibly complex computer game. Suddenly, there's a bug. A character is moving left when they should be moving right, and the programmer has to figure out exactly why that's happening. To find this tiny little error, they have to dig into the data stored in the computer's memory. But here's the catch. The amount of code they have to sift through is just absolutely staggering. If all those memory addresses and values were displayed purely as binary, just endless continuous screens of ones and zeros, the visual overwhelm would be completely unmanageable. Trying to spot a single flipped bit in a massive sea of binary, that's practically impossible for the human eye. And this perfectly illustrates the issue. Think about a standard 16-bit binary number. Imagine having to read 1111001010100101. Now imagine staring at thousands of lines of that. It's a headache waiting to happen. But if you take that exact same value and write it in hexadecimal, it's simply F2A5. It is incredibly obvious how much easier it is to see, copy, and just generally deal with a quick 4-character hex string rather than that massive 16-bit binary mess. So let's move on to section 2. Enter hexadecimal. You can kind of think of this as a base 16 decoder ring that programmers rely on to basically save their sanity. What's really fascinating is just how simple the system actually is once you look under the hood. Hexadecimal is a base 16 number system. For the first 10 values, it just borrows straight from the denary system we use in everyday life, so the digits 0 through 9 are exactly the same. But because it needs 16 distinct digits, it uses the letters A through F to represent the rest. So the denary number 10 becomes A in hex. 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. It's just a really elegant way to pack way more value into a single character. Which brings us nicely to section 3, why programmers love hacks. Listen up, because this is a crucial area for your syllabus. Examiners love asking you to explain the specific benefits of hexadecimal over binary. The real secret sauce to hexadecimal's efficiency? It all comes down to the number 4. One single hexadecimal digit perfectly represents exactly 4 binary digits. When you have a massive string of binary data, you can essentially compress every 4 bits into just one single hex character. Because of that brilliant 4-to-1 conversion, we get a whole laundry list of benefits. Hexadecimal is a much shorter representation of binary. This means it takes up significantly less space on a computer screen, which is great. It's vastly easier for us humans to read, write, and remember. And crucially, for our game developer from earlier, it makes it so much faster to debug and locate those sneaky data errors. But I need you to remember one absolutely crucial fact. Computers only ever process binary. Hexadecimal, that is designed 100% for human benefit. Moving right along to section 4, real-world hexadecimal uses. Because it's one thing to know the theory, but where do we actually see this in the wild? And more importantly, on your exam. I want you to burn these 4 areas into your memory right now. You've got MAC addresses, IP addresses, specifically IPv6, HTML color codes used in web design, and system error codes. Seriously, memorize these 4, because they are an absolute staple in the IGCSE exams for this specific data representation objective. Let's think about one of those in action. Imagine the computer system generating an error message. Instead of spitting out an unreadable, mile-long string of binary when something crashes, the computer gives the programmer a nice, concise error code like 0x1a or 0x20. It's immediate, it's clear, and the programmer can just grab a manual, look up that specific hex code, and find out exactly what part of the system is failing. Another massive use case is the MAC address. A MAC address is a unique identifier physically stamped onto a computer or device right at the manufacturing stage. It uniquely identifies that device on a network. And as you might guess, to keep that long address manageable and readable for us, it's written entirely in hexadecimal format. All right, you've absorbed the theory. Now it is time for Section 5, the IGCSE exam practice quiz. We're going to do a rapid-fire review to test everything we just covered. I'll put the questions out there, and I want you to literally shout the answers out loud before I reveal them. Ready? Let's do this. Question 1. What are the differences between the binary, denary, and hexadecimal number systems? Try to think about the base number for each one. I'll give you a second. Did you get it? Here we go. Binary is a base 2 system, meaning it only uses 2 digits, 0 and 1. Denary, our everyday system, is base 10, using 10 digits. And hexadecimal is our base 16 system, using 16 characters total, 0 through 9 and A through F. Perfect. Let's keep that momentum going. Question 2. Name 3 examples of the use of hexadecimal numbers in computing. I just gave you 4 of them a moment ago. Can you recall at least 3? Shout them out. Let's see how you did. You could have said MAC addresses, error codes, HTML color codes, or IPv6 addresses. If you write down any 3 of those on test day, you just secured full marks for that syllabus objective. Awesome work. Final question. This is the ultimate why question that ties this entire explainer together. Why do programmers use hexadecimal instead of binary for debugging? And the answer is because hexadecimal is a shorter representation of binary. It takes up less space, making it vastly easier for humans to read, understand, and ultimately spot those tiny errors. It saves time, it saves space, and frankly, it saves a programmer's sanity. If you nailed that one, give yourself a huge pat on the back. To wrap up today's explainer, I want to leave you with a quick thought. Look around the room you're in right now. Look at your phone, maybe your laptop, a smart TV, your smartwatch. How many invisible hexadecimal MAC and IP addresses do you think are actively communicating all around you at this exact second? The digital world is literally saturated with hex. And now, you hold a decoder ring. Thanks so much for joining me to decode hexadecimal today. Keep studying hard, trust your notes, and I will see you in the next explainer.